Welcome to your pre-calc additional lesson over completing the square. As you can see here, we're going to use this in all of our conic sections, and I'm not going to read this list, but this is the lesson over circles, ellipses, hyperbolas, and parabolas. And we will need to, in all four of those sections, take our equations in general form and put them into a more useful form for us for graphing and finding key information. So before we get into completing the square, let's review square root property, which we have already gone over in Module 2, Lesson 3. So this is just a 2-example quick reminder of what the square root property is. And so this says, if b is a real number and if a squared equals b, then a equals plus or minus b. So what the goal is to get your a squared, or we'll always have x squared by itself, so get it isolated. And then the opposite of squaring something is to take the square root. And remember, when I have x squared, that square tells me I could have two possible zeros. And so where do we get those two possible zeros from? Well, when I take the square root, we need to remember that we get plus or minus b. So here's our 2 examples to remind us of that square root property. Example 1 says use the square root property to solve, simplify your answers. So I need to isolate my squared portion first. So the first thing I'm going to do is add that 30 over. I still have not isolated the square portion. This is 2 times x squared. So I'm going to divide 2 over and get x squared equals 15. So now that I have x squared by itself, the opposite of squaring x is to take the square root. Now, if I could simplify the square root of 15, I would want to, but the square root of 15 is only 3 times 5, so I don't have a pair of anything that comes out. So my answer here would be x equals plus or minus the square root of 15. Now, we can also use it when it's in this form here. Here, my entire squared portion is already isolated. So to get rid of that square, I can take the square root. So my square root and square cancel, and I'm left with what's under that radical, which was x minus 7. When I take the square root, we're going to get plus or minus. And if I come over here to the side, the square root of 20 is 4 times 5, which is 2 times 2. So we have a pair of 2's that come out. And then that 5 stays in. Now this one, we're going to go one extra step because I don't have x by itself like it is over here. So now we're going to add that 7 over. You can write this one of 2 ways. You can write this as plus or minus 2 square root 5. And then when we move this over, it's going to be a plus 7. I typically, though, like my radicals at the ends, because if you write this sloppy, I can't tell is that plus 7 under the radical or not under the radical. So I will be writing these as 7 plus or minus 2 square root 5 is my final answer. So as long as you keep that neat, you can write it in that order as well. So that's a reminder or a little review of our square root property. And so this is supposed to be part B. Hopefully I'll fix that before you see that. So that's our part B. And it says right here, notice from example 1, part B, that if we write a quadratic equation so that one side is the square of a binomial, we can solve using the square root property. To write the square of a binomial, we write perfect square trinomials, and recall that a perfect square trinomial is a trinomial that can be factored into 2 identical binomials. So right here, these are some examples of perfect square trinomials. What multiplies to 16 but adds up to 8, and that's 4 and 4. 4 plus 4 gives me 8. 4 times 4 gives me 16. Or this right here, what multiplies to 9 and adds up to a -6, and that's -3, -3. -3 plus -3 is -6, but -3 times -3 is a +9. So I'm wanting to write one side of these as a perfect square trinomial, and then I can factor it to a square of binomials. And then highlighted here, the process of writing a quadratic equation so that one side is a perfect square trinomial is called completing the square. So let's go on to the next video and we will do some examples of solving quadratics by completing the square.